Hello students, this is for lab 4 and we're going to be looking at what we see with pressure control, ACPC. Currently I'm on ACVC, as you can tell here on the 890 ACVC, and using your scenario that you'll be working with, I came up with the tidal ideal body weight for this patient is going to be 78 kilograms. And using the normal range for tidal volume, 6 to 8 milliliters per kilogram, I came up with the range of 468 to 624. And I decided just to go with 500. That was kind of a round number, kind of low on the lower end of the range, to minimize any, possible lung injury, barotrauma. So I just decided to go with a little lower number. I could have gone to 475 if I wanted, but 500 is fine. So I want to meet my minute ventilation need. What is normal minute ventilation? 5 to 8 liters per minute, or 5,000 milliliters per minute. So I came up, did the calculation, 6,000 milliliters per minute divided by 500 milliliters that I'm giving the patient. It comes up with a rate of 12. So I already inputted rate of 12, 500, and the peak flow, I just left it Vmax, I left it as is. We'll look at the IE ratio there in a second. But with that, that's I'm generating, here's the respiratory rate, what's being returned from the patient. These are all what we inputted into the ventilator. So we have respiratory rate of 12, tidal volume 500, and minute ventilation, like I said, 6. So that is my goal, is to maintain a minute ventilation of 6. Okay, so let's go back into the settings, and we can see IE ratio here is 1 to 3. Okay, so I want you to do your vent check, do the formulas for PF ratio with the, and you can't, I guess you can do also OI, oxygen index, on these settings here. Okay, and what we're going to do is we're going to switch this patient over to pressure control. So just remember that we're here in the lab, we have a test lung. The test lung is probably, it's what it is, test lung. It's not doing anything other than being normal test lung. So normally, if we are going to have a patient who is on ACVC, and now we're beginning to see the peak inspiratory pressures rise and also plateau. Let me close this window. And we'll do a plateau on here, inspiratory hold, and it's generated a plateau pressure of 27. And I'm going to accept this, save it. I did one earlier, so you see both of them in there. You can see that's kind of normal. In 27 and 30 pip, 27 plateau. It's a normal test lung. You're not going to see much difference. But in a real patient, you will see someone who's got decreased lung compliance. You will see the plateau pressures rising. Okay, and then in that scenario, we use what I've taught you this morning, to when we're switching ACVC to ACPC, we're going to start with a pressure control of the PIP minus 5. Okay, or when they go with the plateau pressure, 27. Usually the lower number would be better. Okay, but since we do not have a normal patient here, and what we're going to do is set this patient up on a pressure control. We're going to start out at 10 to 15. I'm going to go with 15 pressure control. Okay, and but what I want you to do is, before we switch him over, let me close this screen. I want you to do that vent check, write down these numbers. Everything's going to look you know, like this, respiratory rate 500, respiratory 12, tidal volume 500, minute ventilation 6 liters. Fine, you want to put 6.03, 503, that's fine, nothing wrong with that. And you have your plateau pressure, you have your pit, okay? But for this lab, I'm gonna want you to start out with a pressure control of 15, okay? So we're gonna go in there and switch this over to 15. We might have to adjust a few other things in here. So I'm gonna go to pressure control up here, okay? So this one already has 15, okay? So normally I would go in here and adjust it 10 to 15 centimeters of water pressure. So we did that, okay? This, remember, when you're in pressure control, now you have an I time. We don't have flow rate anymore, peak flow. We have I time. That's what you're gonna use to adjust your IE ratio, making your I time longer. You would have to make this time longer, okay? If you're gonna make it your I time shorter, your IE ratio shorter than 1 to 3, make it 1 to 2, we're gonna have to shrink I time to reduce that I time on there. Okay, and then this one also has a new display here. It's called it looks like a little slope and with a P, and it's a percentage, and this is slope, or some places call it a ramp, or there's another term which I didn't quite get it here, but anyways, it's another term for it. And anyhow, we're going to leave it at a default of 70%. And what that is how quickly the pressure is reached within the I time window, within the 1.24 seconds, how quickly that pressure is reached. Either quickly gets in there, the higher the slope, the quicker it's going to go in. The shorter smaller the percentage, the longer it's going to take to get in. So that's going to be patient comfort, and you're going to have to watch the patient and also look at. We'll learn about some of that later on, but we'll leave it at default 70%, and leave that as well with your other ventilators, whatever the percentage is when it's the slope. We just leave it there. Let's go back in here. So that's it. I waited too long. We're in a pressure control. 15, everything is good there. I'm leaving PEEP as it is, FiO2 the way it is. I'm going to go ahead and accept it. Okay, remember the numbers up here. I'm going to show you right now. Tidal volume 500, minute ventilation 6.04. So here we go, accept. So let it run a little bit here so we begin to see a few changes. Okay, so right now we got an alarm that's saying a decreased minute ventilation, or actually even tidal volume, decreased tidal volume. So it's going to alarm a little louder probably, so I'm going to just silence it right now, and I want you to look at it. Now you can see the changes we did. We're in pressure control. We're trying to reduce pressure in the lungs. One of the reasons we go on pressure control is to limit pressure. Okay, so we don't cause any lung injury. Okay, but the problem is when we reduce lung pressure using pressure control on a ventilator, we're beginning to see reduced volumes in the lungs. Right now, I haven't changed anything other. We're on pressure control now. That was it. Pretty much that's all I did. And you can see now your tidal volume significantly reduced, less than half. And look at our minute ventilation is 2.6. So the question is, we need to maintain a minute ventilation of the way it was when we started, 6 liters per minute. Right now it's 2.5, 2.6 liters per minute, significantly less. Okay, so how can we correct this? It's the same way when we first set it up on ACDC. We're going to do the formula using 6 liters per minute, okay? So, and if I'm only ventilating right now at 217, I'm gonna take a guess, I don't have my calculator with me, but if I had 6,000 milliliters, I'm dividing 216 into 6,000, and I'm thinking it's gonna be 330? So, yeah, so 3 times, 30 times 217 is gonna get us close to 6 liters. So we're gonna have to adjust. So what you're gonna do is after you switch from the pressure control, you're going to do a vent check with the alarms so you can see what's going on. Okay, we're gonna silence the alarms, and I'm gonna change respiratory rate to 30 so we can bring the minute ventilation back up to where we had it before. So I'm gonna go to respiratory rate. That's gonna really change your IE ratio, so we're gonna have to change our I time. So I'm gonna go up as far as I can, and now I'm at 24, and it's telling me, you're at basically 1 to 1, and we're not gonna let you go because you're gonna end up being in inverse IE ratio, and we don't wanna do that. So what we're gonna do is we're going to adjust the I time. Remember, it was 1.24 seconds. Well, now we need to make it go in quicker to make I time shorter. So let's bring that down to, let's go to 0.8 seconds. Let's see what that gets us. 0.8 seconds. And now I'm gonna go up with my respiratory rate to 30. What did we say, 30? Yeah. So let's accept it. It's really a tight IE ratio too. We might have to change the I time again. So let's wait here. It's starting at 30 breaths a minute. That's what we set it. Immediately you can see minute ventilation has significantly improved. 6.46. Could have gone down maybe to 20, 24. We'll see if I want to maintain the 6. Okay, I didn't have a calculator, so I didn't get the exact number. So I'm gonna just go down to a respiratory rate of 28, and let's see. That's probably where we need to be, yeah. And so there we go. So you can see now when you're in pressure control, I want you to see the difference. Do a vent check on this, okay? And we're gonna have to adjust your alarms as well, because tidal volume has changed. So let's go back, silence this, go into alarms. Okay, and see that's the one that's going off right now. And even respiratory rate, we're gonna have to tweak that, the alarm limit. So we'll do that. 10 above, it's gonna be 38. Again, 38 is kind of high. I would still stay capped out at 35. Okay, and so tidal volume now, the baseline's 214. Well, you can't go down to 0. So we're gonna have to at least go down, let's go down to 100. So this is where, some variables are not exactly, we're gonna go down to 113. Okay, 110. At least we have an alarm in case it drops. And now we also have spontaneous breaths. If the patient is going to breathe spontaneously, we would want to adjust this one as well. Let's just go down to 105, keep that the same. Okay, alarms are set, accept, and then up here you had a red bar blinking. Now it's green, indicating that we've corrected the problem. I'm going to reset it. Okay, so then you can do a vent check, and then you're going to see what changed, what happened when we went to pressure control. Because you have to reduce the pressure. You're going to have to maintain minute ventilation, and you're going to have to adjust your respiratory rate, and that's going to tweak your IE ratio. So let's see what our IE ratio is now. Okay, So we can see now the IE ratio is 1 to 1.68. So I'm not sure if we're going to be able to add 1 to 3 out of this IE ratio. We can try, and the way to do that, again, we're going to make I time shorter. We're going to shrink it instead of 0.8 seconds. Let's see how far we can go down to bring our IE ratio. So I time, we're going to change that, and let's see. As we're going down, our IE ratio is changing 1 to 2 now, maybe 0.5 seconds. Okay, we have 0.5. Let me go back up. There we go, 3.04, 0.53 seconds. Okay, we were able to accept that. So the I time now, and it'll show you in here, the I time will show you is 0.53 seconds. The expiratory time is 1.61, and total cycle time is 2.14, which you can actually get the total cycle time. Again, 28 into 60, that'll give you your total cycle time. So we're at IE ratio of 1 to 3. Okay, so we achieved what we wanted. We set our alarms, answer the questions on the paper. Also, make note of what we had to do here to maintain minute ventilation. And so we can see that kind of went down with minute ventilation. So if we wanted 6 liters, we're going to have to probably go back up to 28 and see. That's going to tweak our IE ratio. Well, it didn't do too bad. It's 2.1 to 2.77, which is fine. Gives us a total cycle time of 2. And accept that. That's probably going to bring my my minute ventilation back up to up here, there. More like what I'd like to see, 6. But then again, remember, even if we were a little bit lower on minute ventilation, even to 5, somewhere above 5 or above, you're okay. But since we're trying to maintain a 6 liters minute ventilation, with my scenario that I'm doing here, we're good. So I want you to be able to see what happens when we switch over to pressure control from AC/DC, okay?